Okay, so let's get started. We're going to be taking a look at how to set up and work with a spark timing table within our Motec M1 applications. Now, this is going to be taking a look at how to set up a spark timing table for both a naturally aspirated and a forced induction example. What we have to create is a good, safe starting point so that we have a reasonable power output out of our engine so that we can drive and go into full throttle to be able to calibrate our airflow and fuel model first. Then we can come back in and take a look at our spark timing and be able to dial that in to give the best power and torque output out of our engine, which is going to be essentially reaching maximum brake torque or trying to reach maximum brake torque without having knock or pre-ignition occur. So that's always our goal. Now, we're going to learn, again, naturally aspirated, forced induction examples here in this training module. So setting up our spark timing table to suit what we're trying to accomplish with our engine. Now, let's jump in here from our fuel tuning page and let's jump over here to our ignition tuning page. We can find it right here. In this particular screen, we're going to find all the things we need in order to access and tune our spark timing. Now, what we're going to find here is that we have our main spark timing table. We talked about this in the last training module. This is where we command our spark timing to happen at. Now, the spark timing in our table here represents where we want to fire off our spark plug in relation to the piston travel on our compression stroke. If we have a value of 0 degrees here in the table, this represents top dead center between our compression and our power stroke. If we have a value here, something like 38, 39 degrees, this means that we want to initiate our spark event to happen this much before the piston reaches top dead center on our compression stroke. So this would be relative to degrees before top dead center, or BTDC. So as we're looking at the table, we're going to find it has this shape where we have lower spark timing here at low engine speeds. As engine speed increases, we see the spark timing advances, and as engine load increases, the spark time retards or gets lower or gets closer to that 0 degree mark that we're finding here. Now, if we have negative values in our table, this is going to be firing off our spark event on our power stroke, and this would be still BTDC referenced, but we're actually initiating that spark event to happen at after top dead center, and that would be relative to that power stroke. So we can see how this table is shaped. We need to consider what values we place in here and what kind of breakpoint axes we're dealing with. The first thing I want to talk about here, which is a very, very important thing to decide before you start doing any tuning with your Motec, it's going to be in our setup and configuration that we need to make sure is correct. What we're going to notice at the table here is based on engine load normalized, and it's a percentage. It also is based on engine speed at the top. This engine load normalized is something that we have to consider before we do any actual tuning. So it's going to be in our base setup. We need to make sure that we have this pointed at the correct parameter, because this can represent 3 different things in our software. Let's talk about that here real quick. We're going to move from our tuning window and jump down here under setup. Now, under our setup, under basic setup, we're going to find here, if we move down our list, we see engine load normalized mode. We can see right here it's set to inlet manifold pressure. We do have another 2 options besides inlet manifold pressure. Let's discuss what this all means. If we have this set to our normal option, engine load normalized will be a function of engine load. We've talked about that when we were looking here at our volumetric efficiency table here. So looking here, fuel tuning, we see that we have our inlet manifold pressure versus engine speed, and this represents the percentage of cylinder filling that's going on in our engine. After it passes through all of our airflow modeling, we're going to be left with something called engine load. Now, engine load is going to represent our air mass. In this case, engine load will be what's referenced and used as an engine load normalized percent if we have that option selected here. Let's go back into setup. If we have our option selected under normal. Now, we typically don't utilize this as the axes into our spark timing table, but it is an option. You have to be aware as you're calibrating and tuning your volumetric efficiency table. That will affect your engine load calculation, the air mass calculation, because as we move our VE values up or down in the VE table, that'll drive up or down your air mass estimation, and therefore drives up or down your engine load. That will rescale, so to speak, where your spark timing is sourced from in your table. So again, if engine load normalized is going to be a function essentially of your air mass, if you're telling the volumetric or you're calibrating the volumetric efficiency table and you're saying to the Motec, well, the engine's ingesting more or less airflow, that'll drive up and down your engine load parameter. Engine load normalized then will be re-indexing here to different portions of the spark timing table. This is typically not an option that we choose, but I wanted to mention it because it can be confusing, and you should realize that engine load normalized can be a function essentially of air mass.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.